Good morning, everybody. I am Davide Pinchiroli, from architect and BIM manager from Conack Construction. Just a quick introduction of myself. I graduated as an architect in 2010, and since then have worked on several different architectural offices between Milan and Florence in Italy. I approached the BIM field in 2018, where I got the BIM Specialist certification. I moved to Ireland in January 2019, where I worked as an architectural designer and BIM specialist for C.W. O'Brien Architects. After 2 years, I became senior architectural designer and BIM coordinator. In 2022, I graduated with honors in a 2-year master course in project management and construction work with BIM. From July 23, I've held the role of BIM manager for Conack Construction. Conack is one of the biggest construction companies in Ireland. Conack was founded in 2008 and is based in Limerick, with regional offices in Cork, Galway, and Dublin. Company's key activities are general building, main contractor, with over 200 people directly employed. Conack's portfolio extends through healthcare, retail, commercial, industrial, civics, educational, residential, refurbishment, and fit-out sectors. The sites I'm currently following under construction with BIM methodology are TC1 Cherrywood, Dublin, 317 apartments, Nina New Hospital Extension, 50 bedrooms, San Camillus Elderly Care, 75 bedrooms in Limerick, and Gas Network Ireland Building, Gaswork Road, Cork. As a BIM manager in the construction field, I thought it would be interesting to share my thesis work done along with Giulia Mazzini, project architect for PMCA Architects, Dublin. This work was presented on July 22 as a final work of a 2-year master's in project management and BIM management from the Polytechnic University of Milan. This presentation will be focused on our thesis path established within the project of the new large university hospital complex in Odense, Denmark, currently under construction. In this slide, we can see some details of the project. The site area, 860,000 square meters. Total building area, 250,000 square meters. Total number of rooms, 10,000. Total budget, 700 million. General contractor was CMB Darby. A 6-cluster buildings developed around a long central block called the Science Axis, connecting the 5-story hospital complex really into the University of Southern Denmark on the back. Our contribution aimed to implement the BIM 5D management process, as well as simplify and standardize the internal procedure of the general contractor during the construction phase. These procedures were related to the budgeting of the construction elements and part of our implementation intended to make them applicable regardless of the type, size, and project construction size. We started by studying the managerial process by the main contractor. Our focus was on the organization of the work breakdown structures for this project, along with the cost-revenue analysis as budgeted at the tender stage. From here, we arrived at the process implementation. The use of structured codes allowed the achievement of a cost WBS useful for data extraction during the budgeting phase at the subsequent planning and construction stage. This slide shows the work breakdown structure used by the general contractor on the Odense project at the as-is status. As you can see, it has broken down into 7 levels, starting from the first one, the project itself, then the site, then the building, then the levels floors, then the project categories such as structure, facade, ceiling, floors, and so on, then zones, and at the final one, WBS description. For the purpose of our thesis, we analyzed the horizontal stratigraphy script coded as FL01, part of the level 7 WBS description. By adding a new level of WBS, which breaks down the horizontal stratigraphy into types, such as straight 1, straight type 02, and by adding a new level to the cost breakdown structure, such as the cost breakdown element CBE, we were theoretically able to link the WBS, therefore every 3D elements within the model, to the cost of every specific street type in square meter coming from the cost breakdown structure. Once the BIM requirement scheme for the 5D phase was completed, we started the implementation of the native Revit BIM models, reflecting the codified structure established in the previous stage. By using shared parameters, shadows, and filters, we were able to add a new set of parameters to every element in the model, reflecting the new WBS level 8, as well as coding all the materials by CitA. At this point, we uploaded the model to a construction project management software. We choose to use CPM, developed by Team Systems. Another well-known software for construction project management is Bexel Manager. This type of software allows you to monitor the 3D, 4D, and 5D phase of a project on a single software interface. By uploading the ISC 3D models, all the information related to the quantities is directly linked into the construction project management software, as well as the cost items. Cost and revenue values are also included in this project. Thanks to the previously assigned coding system, CPM also allowed us to filter and organize the items of the bill of quantities. Within the CPM, we populated every CBE cost breakdown element with their supply costs and installation costs, and more deeply with the cost code, CTE, item code, and business partner. We now have all the 3D elements directly linked to their material costs and revenues within a single software. These inputs have been arranged in dynamic datasets according to the specific purpose of each construction stage, along with the planning time for each cycle. Now that every cost and revenue broken down by supply and installation are linked into the 3D objects, we are ready to run a 4D time scheduling phase as a baseline. By filling in proper fields such as starting date and finishing date, all the dependencies for each element, we can say we have a 4D phase directly linked to the 3D objects, directly linked to the cost and revenue, each broken down to supply and installation at the relative business partner. The only missing part of the process is how to connect what's happening on site on a daily, weekly basis to the models in order to monitor the site performances. In terms of timing, there is a proper section on CPM where it's possible to update the percentages of completion of each 3D element on a daily, weekly basis. This section is separated from the 4D one, but totally linked into it. This allows you an easy comparison between what has been scheduled and what has been built on site on a specific date. This just mentioned process is known as earned value. In terms of materials, there is another proper section on CPM in which you can upload delivery notes, timesheets, reports, work progress status, and everything related to materials that have been delivered on site associated with current costs paid for the specific delivery material. This process is known as actual costs. We are now able to run the earned value analysis within CPM software. As we all know, the earned value analysis provides a method that permits the project to measure by the progress achieved by the comparison between three data sources: planned value, PV, earned value, EV, and actual cost, AC. I've already introduced the earned value and the actual cost, but we already have the planned value as well, which is the initial baseline that is quantities taken from the 3D models and time schedule taken from the previously shown 4D phase. The use of a single management software for the 4D and 5D phases simplified the general workflow and in turn allowed to integrate control required for the construction firm to always generate an optimal value stream. As the construction phase proceeds, the data received from the construction side as the work status and progress status were also updated and analyzed within the software. The earned value analysis allows us to compare the construction progress on site with what was originally planned. By taking advantage of the potential of the CPM software and business intelligence software such as Microsoft Power BI, we could summarize and focus our attention on the most significant result for the project itself, even more for its sponsors. Some of the rich goals have been the comparison between what was planned and the real costs and revenues at the material level, the incidence of the labor and material costs on a single work package, a work detail costs and time schedule analysis during the building stage. The aim of this implementation process was to improve the management performance of the project during the construction phase, thanks to the software and logic of the BIM and project management. 5D BIMs allows linking of the 3D model to budgetary and costing heads in real time, which simplifies budgeting, speeds up decision making, and makes your BIM model more accurate. Thank you, everybody.